Okay, so here's another important distinction that needs to be made in the class, the difference between your average rate of change and your instantaneous rate of change. So I want to read this problem that is from Tan's 2009 book. And it reads, you guys should have this, it's page 8. I'm not going to zoom in too much because you should be reading it as I'm reading along. It says, as broadband internet grows more popular, video services such as YouTube will continue to expand. The number of online viewers is projected to grow according to the rule n of t equals 52t to the 0.531, where t equals 1 corresponds to 2003, and t runs from 1 to 10. What will the projected number of online viewers be in 2010? All right, so I guess we have to start thinking about what 2010 would be. That would be the first thing that would be helpful. So let's see. T equals 1 equals 2003. So let's see. 2010, which is 7 years after that, is t equals 8. Okay. So the very first question is basically just asking you what happens after 8 years. So we should be able to find that one fairly quickly by just doing n of 8. This equals 52 times 8 to the 0.531. All right, so you just plug that in your calculator. And I got 156.87. Okay, now that's not going to make any sense because you can't have a fraction of a viewer. So I'm going to say that this is approximately equal to 157 viewers. Okay. The next question says, what is the average rate of change in the projected number of viewers from 2003 to 2006? And then the question after that, this one says, how fast will the projected number of viewers be changing in 2010? Another way of saying that is, at what rate will the projected number of online viewers be changing in 2010? All right. Now, you really need to be paying attention to these because they are talking about different types of rates of change, right? Both of them say rate of change. This says rate of change, but this one says average. And this one doesn't say, it doesn't have a specific description in front of the rate of change. However, they only give you one time. Okay, so this one's saying, well, what's happening roughly between 2003 and 2006? This one says what happens at 2010. Okay, so this is the instantaneous rate of change because they're saying at this moment, how is your function changing? Whereas this says what happens between two values of x. All right, so let me try to see if I can illustrate that otherwise. It looks like it's going to be too easy to do that, so I'll just do the math for you instead. All right, so your average rate of change, this is the one you did in high school. They're giving you 2 times, 2003 and 2006. Please make sure that you're careful to change those times in terms of what they've given you here. T equals 1 is 2003. So in essence, what they've done is they're trying to tell you this is t equals 1, and this is 3 years later. This is t equals 4. Okay, so we need to find the 2 points that they're referencing. So on the one hand, they have t equals 1. And then the y value that's associated with that, you'll notice I'm going back to the original function. So this is 52 times 1 to the 0.531, right? And then we also need to find out what happens for t equals 4. So t equals 4. And we're going back to our original function, which is 52 times 4 to 0.531. Right? So t equals 1 and then the population associated with that, and t equals 4 and the population associated with that. And all we're going to do is what you did in high school, which was change in y over change in x. So let's see what those are. If we do the math, we get that the points of which we speak are 152, 1 comma 52, and also 4, .57. And yes, I know that the decimal isn't going to make any sense. I'll clean that up in a minute. All right. So as I mentioned, this says the average rate of change, right? So we're doing the one that's in high school. It says simply just do change in y over change in x. So how do we do that? Then our average rate of change is simply just 108.57 minus 52 all over 4 minus 1. All right, so if I do that math, let's see what I come up with. 108.57 minus 52 divided by 3 in essence. And that gives me, this is approximately 19, right? 18.85, and you can leave it in that 0.86 rather. Okay, now I need to be really careful because I'm going to have to consider the units that are attached to this. So in the numerator, you have viewers, right? That was your n of t. The 52 was what you got when you plugged your numbers back into your n of t. And then the 108.57 also what you got when you went back to your n of t. So in the numerator, you'll notice it says that represents the number of online viewers in millions. So this is million viewers. And in your denominator, you have times, right? They give you 2003 and 2006, and those are in years per year, right? If I put a 1 here. All right, so that's perfectly fine. Let me show you that number. Okay, so if you look at that and you say, wait a minute, she rounded that earlier number, why didn't she round it here? Well, I'll tell you that I likely should not have rounded that earlier number because this makes sense. 18.86 million is basically 18,860,000 viewers approximately, right? So that is perfectly legitimate. It's something that makes sense. Up here, I was not paying attention to my units, and so I want to go back and clean that up. Okay, so in this earlier problem, I ended up with, and let me clean it up, 156.87, and I was disregarding the fact that it says right there, right? It says that this is in millions of viewers, right? So you always have to be paying attention to the units because sometimes having a fraction of whatever your unit is can make sense, and at others it really doesn't. So if this was viewers, then yes, it would make sense to have a fraction of a viewer, but it's in millions of viewers. All right, so what this is indicating is that from 2003 to 2006, you would expect your number of viewers to be going up by 18.86 million viewers for every year. All right, let me write that as a sentence because it's going to be important for you guys to be able to make a general statement. So on average, we can start that because this is an approximation of what happened between two time periods, 2003 and 2006. The viewers increase by 18.86 million viewers each year from 2003 to 2006, right? So this is generally how your viewership is increasing. Now we need to compare that to this next question. Okay, so hopefully you guys are looking at that third question because that one is important also. It's asking something different. Okay, so let me show you that one. I'm right here. It says, how fast will the projected number of online viewers be changing in 2010? So in a specific moment. Okay, this is no longer the average rate of change. You're not doing change in y over change in x. This one is the derivative. Okay, so let me write down what our original function was. We started off with n of t equals 52 times t to the 0.531. So then when we take the derivative of that, then we should be able to use our power rule. So let me show you the original function so that you'll be with me. 52t to the 0.531. So here, when I get to my derivative, I get n prime of t equals 52. Bring the power down, 0.531. t to the 0.531 minus 1. Right? Same steps. Right? And the only reason that I took the derivative here is because it said find that instantaneous rate of change, that specific, what's happening at a specific time, 2010. All right. So simplifying this, n prime of t equals, let's see, so 52 times 0.531, I got 27.612 t to the negative 0.469 rather. So what I'm going to do now is I'm going to plug the equivalent of 2010 into that problem. All right, this is going to cause me to do a little bit of thinking. So let's see. They said t equals 1 is 2003. So 2010 is 7 years later. That should be t equals 8. Okay, so I'm trying to find n prime of 8. So this is 27.612 times 8 to the negative 0.469. An instantaneous rate of change using my slope generating machine. So let's see, 27.612 times 8 raised to the negative 0.469. And I got that this is equal to 10.41. Now the beautiful thing about a problem like this is that the units for this one is the exact same thing as same as the units for the average rate of change. So this is going to be millions of viewers per 1 year. Okay, so I'm going to write out what this means, just as I did with the average rate of change. So Let's see. In 2010, the number of viewers increased, by 10.41 million viewers per year. All right, notice the contrast. This isn't telling you a range of dates, it's telling you one date, 2010. It's telling you how your number of viewers is changing at that particular moment.